In this video, we're going to explore a simple way to use logarithms in order to find an unknown value. The half-life of flerovium is about 1.3167 minutes. If you start with 92 grams at 8 o'clock a.m., at what time will there be 17.5 grams remaining? By giving us the half-life, we know how long it takes for this element to decay to half its original value. What we don't know is the rate at which it's decaying for every 1 minute that passes by. To figure this out, we're going to write an exponential function. The standard form of an exponential function is written f of x equals a times b raised to the x. The a represents the initial or starting value, b represents the growth or decay rate, x is our independent variable, for this problem minutes, and f of x represents our dependent variable, or the amount of grams left after x minutes have passed. In order to write a function to represent this scenario, we need an a value and a b value. Using the information given, we can identify that 92 is the starting value. We also have the clue of half-life. Half-life means how long it takes for a substance to decay to half of its original value. Using this information, we can conclude that after about 1.3167 minutes, the original amount of 92 grams will have decayed to half of its mass, or 46. Using this information and our equation, we can now solve for b. Because this problem has to do with half-life, we could actually pick a variety of different starting values. The key here is that your output after 1.3167 minutes has to be half of your starting value. So it doesn't matter if we use 100 as our starting value and 50 as our ending, or even 1 and 1/2. All of these examples will reduce to the same equation, which will give us the same b value. Now that we have an exponential function to model our scenario, we can use this to answer a variety of questions. Looking at the problem from the first page, we would like to identify if I start with 92 grams, at what time will I have 17.5 grams? In this problem, x is my unknown. To begin, divide both sides by 92. You can divide here and find a decimal approximation, but I prefer to leave my calculations until the end to get the most exact answer possible. Here is where we need logarithms in order to find x. Right now, x is in the exponent. We don't have a great way of solving for that without using logarithms. Here you have two choices. You can convert right to logarithmic form and find the answer on your calculator, or you can take the log of both sides and solve this algebraically. I'll show you both ways. Converting to log form means that the number 0.5907 will become the base of your log, and you will be taking the log of the fraction on that other side. Use the change of base formula in order to put this in your calculator and find the decimal approximation for x. You could arrive at the same answer by taking the log of both sides of your equation. Using one of our properties of logarithms, this allows me to take the x out of the exponent and write it out in front of the logarithm on that side. Your final step is to divide on both sides and then use your calculator to find the decimal approximation for x. Notice any similarities? If we look back at the original question, it's actually asking us for what time. If time 0 is at 8 o'clock in the morning, we need to add 3 minutes and 0.15 of a minute, which is about 9 seconds. Want more practice? You can use our original equation to solve for the time it takes for our 92 grams to decay to any amount. Want to learn more? Visit the Reduce Simply YouTube page.